Hello, this is our week 3, very first day Monday reflection video, and it's also going to preview what we're going to look at tomorrow in day 2 with continuous domain. Now, we were doing discrete domain and range today, and you'll notice the difference between this graph is that our other graphs just had a bunch of what looked like dots, which are our points, but they weren't connected in any way. There was no line, segment, or curve connecting them. And this graph has 2 points showing that they are connected. I'm going to highlight, we've got one little connector here, and then we've got a second one here where it bends the other direction. So since these are connected, this is a different type of graph called a continuous graph. Discrete graphs are not connected. And today we're going to look at, or tomorrow we're going to look at continuous, so domain only. So I'm going to sort of show you an idea of how that's going to work. Now, since it is domain, we're worried about we're going to look at X numbers. So I'm going to put this highlighter that I've already got up here on my X axis to remind myself that when I'm writing down my numbers or my values, that I'm making sure I'm getting them from the X axis. And since this is domain and that's the x-axis, we're going side to side. Now, we can't list everything that's on here separately like we did with discrete, because while we do have a point here and we do have a point here, we've also got points here and there, and then we've got all these little points in between lines. There's just no way to list them all. So we don't actually try to list them all because we would miss some, and we would probably get some wrong because we would have to sort of guess those values since they're in between lines. We have to show sort of like boundary numbers or boundary points, and that everything else is in between those. So that's what we're going to do. We're going to find our boundaries. And to do that, I like to use this yellow highlighter that I can use sort of move left and right since I'm dealing with left and right because this is side to side for the X, the domain. So my first one that I'm going to try to get is my left boundary. And what a lot of people will do is they'll try to line it up with the points. If there are endpoints on there, like this one does have an endpoint right there. But endpoints, while nice, don't always make the boundaries because you'll see on this one, if I leave it there, we still have a piece of the red graph to the left of that. And I need to get all the way to the left, not just a part of the way. So I need to keep moving my boundary until I get all the way to the left. And there I am, right there at that, basically that bend, that little elbow part. None of the red goes past that. So that is the true left boundary. So what I'm gonna do is I'm gonna move that over just a little bit, and I'm gonna draw in something that's sort of like a little highlighted line to that X. Because remember, I always want to know the X. So that's that spot where that boundary is. And from my origin, I'm going to count it over. Here's my origin. 1, 2, 3, 4 over from the origin. And since it's to the left, it's a -4. I'm going to circle that just to remind myself that is my left boundary. Then I'm going to do the same with the right. I'm going to move it all the way over until I get all the way to the farthest right that it's at. And this time it does line up with one of the points or the dots. And then I'm going to remember where that is on my x-axis. I'm going to come back. I'm going to get my blue. And once again, I'm going to draw it down from that spot. That's sort of a highlighter on it. I'm going to count it over from the origin. Here's my origin. 1, 2, 3, 4, 5, 6. So this is 6 over, and it's positive because it's to the right. So what I'm basically telling myself is that it's everything in between that -4 and that 6. I'm actually going to highlight that again so that becomes a little bit more obvious. I'm going to use this one. So it's everything in between here. And if I remove this one, now you can see that's where the domain is. It's all the numbers in between the -4 and the +6. But I need some way to write that to show that it's all those numbers in between there. And we do have a way to write that. The first thing I'm going to do is, since we read left to right, I'm going to write it left to right, just like we kind of do here. And I'm going to, like in between them, remind myself that this is X numbers because that's domain. And basically, this is the way you start off writing it. You write the left boundary, you write the right boundary, and notice you have space, and then you put the letter that you need. And domain is always X, so I'm going to use that X number. And then you need a symbol to show that it's the numbers in between those, and for that we use the less than symbol. So that means all the numbers in between a -4 and a 6, but there's one more piece of it. You'll notice our dots are different. We have what's called a closed-in dot, which I'm going to do like this up here. And we have an open dot that looks like that. And they mean different things. A closed-in dot means that that point's actually included, it touches it. An open dot, like we have right here, which I'm going to highlight because it's one of our boundary numbers, means that it's not included. It doesn't actually ever reach the 6. It gets very close to the 6, but it doesn't ever reach it, kind of like maybe 5.999. Well, if you underline the underline, like if I underline it like that, that means that it actually reaches it. So we shouldn't have the underline there. The underline goes with the closed dot. So I'm going to leave that 6 symbol without the underline. But this -4 over here, even though it doesn't have a dot, there really is a dot there. They just don't show it because there's dots all along this. So there really is a dot here. And since it's on the line segment, then it's a closed-in dot. So that -4 should have the underline. And this is the domain of this graph. It's everything in between and including a -4 and a 6. Or another way to say that, it's all the numbers greater than or equal to a -4 and less than a 6.